Good morning, good afternoon, good evening, class. Welcome to our course, Mathematical Modeling with MATLAB Applications. So today I will be discussing to you the introduction of this course, and particularly it's on the elements of a mathematical models. Okay. So the use of modeling in research is one of the latest advances in research methodologies, and its recent popularity can be attributed to the number of factors. It could be because of the growth and advancement in information technology, or perhaps it contributed the most to its rising prominence in social sciences and education research, because mathematical modeling is such a very powerful tool. It can be applied to almost all fields, from social sciences, education research, psychology, and even in fields na feeling ninyo abi ninyong dili siya ma-apply, but it can really be applied, because quantifying things is a lot more powerful than we can ever imagine. Okay, I'll just close this. Okay. So in this session, we will take time to answer and give light to the following questions. And these are frequently asked questions by most readers and starters. So what is a model? What is a mathematical model? So in particular, what is it? So why do we do modeling? So what? Can mathematical models really explain or contribute to a deeper understanding of a phenomenon? So those are valid questions that one may raise. So the purpose of every model are the following. So tago siya two main reasons. That is to describe a real-life phenomenon and to predict the outcomes of a phenomenon. Okay. So mo na siya ang iyang core gid niya. So to describe a real-life phenomenon and to predict unsay mga possible outcomes. For example, why do we have weather? Why do we have changes in the weather, right? From a very smooth weather, and then later in the afternoon we will experience drastic change. For example, na a thunderstorm naggalit, right? So we want to describe that phenomenon, and we want to somehow, as much as possible, predict what will be the outcome of such. So it's actually the latter purpose, that is to predict the outcomes of a certain phenomenon, that makes modeling quite attractive for both physical and social scientists. So the ability of the ability of the modeler to predict phenomenon. So kani siya nga aspect. So it is the ability to predict a phenomenon depends on how well the modeler is able to mimic the important aspects of the phenomenon the model is trying to describe. So by the end of this session, you will get a feel of what modeling is all about, and you'll be able to generate a conceptual model from a given scenario. So I just want to reiterate that this course is all about mathematical modeling. So I will be giving you examples of this mathematical modeling and how is it done and applied in different fields. And you will really observe and realize how powerful it is. Okay. Mathematical modeling is by nature phrased in the language of mathematics. So we cannot avoid this one. It is really phrased in the language of mathematics, because after all, if you really want to understand the universe, then you must know its language that it is speaking to us, and that is through mathematics. So the precision and parsimony offered by mathematical language makes it the most efficient way of handling models. So it is therefore important that you have some working knowledge of algebra, trigonometry, calculus, statistics, and numerical analysis. So preferably with a working knowledge on some programming languages. Pwede siya C, you already know C. You have also C++, which is just an extension or object-oriented type nga language. And Python, you've experienced Python in the previous SEM. And R is somewhat similar to MATLAB. But in our case, we will be using MATLAB as our main language because of its ease and presence of a lot of libraries that we can use in studying things. So models, so when we speak of models, we often imagine, right, images of people walking up and down on a platform. Kanang model din bitaw, diba? So when we watch the models on stage, we are subconsciously told that this is how you would look like if you wear those garments nga ilang you wear. So thus, a model is a standard or example for imitation or comparison, a representation, right? It is a representation generally in miniature to show the construction or appearance of something. It is also an image in clay, wax, or the like, to be reproduced in more durable material. Also, a model is a person or thing that serves as a subject for an artist, a sculptor, or a writer, many more. Another description is a model is somehow used to help visualize something, example, an atom, that cannot be directly observed. So that's how model is defined according to Webster Dictionary that was published or posted in 2000. Let's take a look at one example of how a model works and how it is used, especially in physical science. Now, you're already familiar with the model of an atom. Now, you can imagine right now and conjure image of what an atom looks like. So you already have this idea on what an atom looks like, right? So it must somehow looks like this. But we already know that this is not actually the most accurate or the correct model of what an atom is. So this is just the model that they used when it was not yet discovered that actually electrons are not circling around literally on the nucleus, but it's actually a cloud or something. But for this case, just for demonstration's sake, we'll be using this picture as a model that will represent what an atom looks like. Okay. So the model of an atom, which we cannot see it in our naked eye, it is often a series of concentric circles with nucleus and dots with negative signs, so electrons moving rapidly around the nucleus. Then you might ask these questions: why are the electrons moving around the nucleus in this model? Right? So if an atom looks like the picture shown in this slide, then we can certainly begin to ask interesting questions like, why are the electrons moving around the nucleus? Maybe there is something in the nucleus that repels the electrons and keep them steady in their orbit. Another question that you might raise is, will the atoms have the same number of electrons? What do you think? So in fact, we know from the basic chemistry that the atomic structure of different chemicals have different number of electrons. Now the definition of a model suggests that modeling is a process or undertaking in which cognitive thinking is involved. We think and make models which can somehow describe how certain things behave the way they do. So these objects of interest can be described in many and varied ways. We can opt to use words to describe model, or in sketches maybe, for as long as your capability or talent permits. So physical models such as sculpture or computer programs or even mathematical formulas, you can use those to model something. So essentially, modeling is a process which can be expressed in several media or languages. And this can also be done by using two or more of the aforementioned languages simultaneously. It could be mathematical, computer programs, or doing some sketch and drawings, just to have a clearer perspective or understanding of what you are trying to describe. So since we are interested in mathematics for this course, because this is mathematical modeling, we'll look back and reflect on the given definition. So what is mathematical modeling? And why do we do it? So what? So mathematical modeling is simply the use of mathematics to describe real-world phenomena. It also investigates and seeks answers to some relevant questions that is being observed in the world. Mathematical modeling not only describes systems in the real-world phenomena, but it can also precisely explain such events, which gives light and significant ideas which are formerly known to be mysterious and unexplainable. In physics, there are a lot of things na gibuhat sa mga scientists before, physicists, in trying to explain let's say mysterious phenomena or somehow unexplainable siya. Let's say the presence of fire. Why do we have fire? Why do objects emit fire when they are burned? Right? So why lightning occurs, and then why is it that when there's lightning then there's thunder? Right? So people in the olden times were also curious about it. So the idea is naa siya curiosity nga nanong inaana man na siya, then they want answers, right? They want answer to some relevant questions. So and then once nga naana na siya nga idea or question sa imong mind, then you seek to find answers. How? By using different means. It could be through simulation, could be you can use mathematics to arrive at something that would explain the phenomena that you are trying to give light or answers to. So models are important since it describes our belief and concepts of how the real world functions and behaves, because after all, our world, our universe is full of mystery. So although some of the things nga seem unexplainable before are now well explained today. Some of the things nga mysterious before, but now it's not mysterious anymore. For example, eclipse. So before, mysterious kaya na siya. It must be intervened by gods, or works by some kind of their gods. But now we can somehow explain it in scientific ways. And there are also things nga mysterious pa karon nga dili pa siya ma-explain. For example, dark matter, dark energy, the nature of black hole. Those are the things na we somehow find it unexplainable and mysterious as of now, but in the near future, in the not so distant future, it will be answered, hopefully. So this type of modeling, unlike any other modeling, uses mathematics heavily, okay, as the language to test ideas and make predictions about the real world, such as physics, engineering, physiology, ecology, wildlife management, chemistry, economics, and many more. Okay, so indeed, mathematics, which is our medium in this context, has many advantages. So this is how the modeling is being processed. So it is an iterative process. So it is an iterative process. You have your real world data, then you formulate model or explanation, then you do some analysis, then you make mathematical conclusions if it coincides with the real world and your model, and then you interpret by making predictions and explanation, then you test Tapos, if dili pa jud siya doon sa real world data, then you reformulate or improve your model, and then and so on, right? So modeling in this example, we use heavily mathematics. So why do we use mathematics? Because first, it is a very precise language which helps us in formulating our ideas, which includes correctly identifying underlying assumption. Second, mathematics is a concise language which as mentioned earlier, it is easier to manipulate because of its parsimony and well-defined rules. Another is that all mathematical theories and mathematical formulations that mathematicians have proved over several decades are already at our disposal. So naana tanan sa ato, all we have to do is use it. Still another, computers can be used to perform numerical calculations to approximate solutions if in some special cases dili siya ma-solve o lisod siya i-solve ba o wala siya closed form or exact solution. So what is the main objective of mathematical modeling, and what can it achieve? So mathematical modeling can be used for a number of reasons. This may include one or more of the following. So first, modeling can help provide and develop a scientific understanding through quantitative process, and the model identifies the critical factors that influence a phenomenon that is being observed in crisp mathematical form. Also, it is of great importance in decision making, which may include tactical decisions as well as strategic decisions. And the predictive value of the mathematical or metric model allows decision makers to plan ahead in a manner that is optimally beneficial to the organization. So scientists make use of mathematical models in making a very wise and good decisions in improving their organizations. So finally, modeling can also be used to test the effect of changes in the system. Now, what are these types of models? Let's dive into this. So in research, metric modeling or mathematical modeling is one of the vital and basic approaches in describing and explaining interesting phenomena. This can also be extended to mathematically predict certain events. In other words, metric modeling is a powerful tool in explaining things which are yet to be observed, happen, or confirmed. So naadiri man gud ang interesting part. We want to make predictions. We want to know the future, right? We want to know if mo decide ba kita nga mo invest on these things, let's say on stocks, if okay ba ang iyahang performance or behavior sa stocks 5 years from now, right? So we want to be sure. Mathematical models can be broadly classified into 3 divisions. So for the first division, it is based on the output or outcome they predict. For the second division, it pertains to models when one is considering the level on which the model is based. And then the third division is the simulation model. So for the division 1, this model is based on the output or outcome they predict. So under this division, we have the deterministic modeling. It is a metric modeling which precisely determines the outcome to existing and relationships wherein random variation is totally ignored. In addition, this model will always be likely to produce the same output from a given input. So deterministic modeling is heavily used, or it's the main core of classical mechanics. So we've undergone classical mechanics, the Newtonian mechanics. You are given with this input, then 100% sure or you are accurate that this will be the output based on this given input. Let's say, if I want to throw this ball with a certain velocity, when will it land, how it will land, and where it will land, it will determine exactly based on this deterministic model. The example of which we have free fall, projectile motion, and the rolling of the ball on a hill. Then we also have the stochastic model. So it is a metric modeling which precisely determines the outcome through existing and known relationships wherein random variation is totally ignored. So in addition, this model, I think I made a mistake in wait. Okay, ako na siyang gi-edit eh. Kaganina is mali to ang iyang definition because it's the same definition for the deterministic. Okay. So for stochastic model, it is actually a mathematical model that incorporates uncertainties and random or chance occurrence of the events being modeled. And the outcomes are not exactly exact results but are given probabilistic interpretations. So I'm sorry about this typo. Examples, case stock market, we also have earthquake, and one perfect example in physics is the quantum mechanics. So we are in quantum mechanics, physicists are also able to predict the outcome, but in terms of probabilistic na siya. Okay. Now how about for the type 2 division? Division 2 model. So we have the mechanistic model. These are based on understanding of the behavior of a system's components. Then we also have the empirical model, which are based on direct observation, measurement, and extensive data record. So dili mo fall ang mga say heavily using data, so for data science. Then lastly we have the division 3, which magamit po dani sa tuang course. We have the simulation models. So simulation models are numerical models that and are often used when large-scale computations are needed in order to see the outcomes of the model. Example, business forecast, weather forecast, and so on. Many more. Now, what are the characteristics of this model or characteristics of a model? So a model is an important tool in research and in all scientific disciplines. Not surprisingly, models used across disciplines may vary in some aspects, such as in their content, appearance, function, which can be categorized accordingly as mentioned in the previous slides. Although models differ in various scientific disciplines, there are certain other features that are shared by all models, regardless of discipline. Now, the following are the characteristics that a model must have and satisfy. First, a model is always related to the subject and it's designed for a special purpose. Okay, a subject of interest could be an object, could be a device, could be a phenomenon, an event, a process, an idea, etc. So as stated in the previous slide, a model is always an abstract representation of the subject, which will be quite different from the object of interest. Okay? So nevertheless, when one looks at the subject and the model, it should be possible to identify and distinguish the differences between the two. Next, a model serves as a tool in research to obtain information about the subject, which itself cannot be easily observed or measured directly. So basically, models are used to learn from things which are already or previously known. By comparing it to things which are more familiar with, we can obtain useful information which are valuable to research undertakings. Because the purpose of the model in research is mostly to explain things which seem unexplainable and predict certain outcomes. Diha man nga part ang ato ang gusto. A model also bears some analogies to the subject. So certain aspects of the subject must be present in the model. Then also a model must contain key players or elements that will describe the scenario. So every model has an actor or elements. Each of the elements or key players may interact with one another, so that the specification of the rule of interaction is necessary, na required gid siya. And lastly, a model can evolve through an iterative process. So the model gets refined. So dili per no model mo stay siya o kana siya nga definition. It will always evolve depending on on the things nga na-observe mo sa real data, because after all the ultimate judge sa imong model is unsay say sa real data. If your model is not in accordance with the real data, then two things sa imong pwede buhaton: i-discard ang imong model or you improve it. Now, these are some samples of models that you might be interested to dig in or study further. So, suppose you want, first nga example. Suppose you want to investigate why and when a student in a certain classroom setting of a given university will most likely participate in the discussion. So, interesting siya nga question, right? So we might be interested in predicting the effects of the classroom environment in relation to the student participation. Another factor we might consider is the student's disposition or family background, which is related to the way he or she was raised. This could be directly attributed as to the way students respond and participate. In addition, the teacher's pedagogical skill could also be one factor to consider na nganong mo-participate ang student or di. So this may have a direct implication to student involvement in the discussion. So this may be a good problem to study using mathematical modeling. One can directly identify the key elements or actors, the interaction between the elements and its characteristic in each of the following scenarios. Second is, you may be interested to inquire on the management of a certain business. For instance, in the management of chicken eggs, it may be important to determine the optimal sustainable yield of a harvest and the sensitivity of the species to population fluctuations caused by harvesting. Still another example is, or sample of models is, this scenario wherein you want to study the effect of quality to access in higher education. So quality may act as a barrier to access in higher education, because high-quality universities are highly selective. So, ma-notice nimo, if the more nga taas ang quality sa university, mas taas ang ilahang rejection pod, right? If you take a look at Harvard, so ang Harvard is known to be of high quality gina siya nga university, and known po na sila sa ilahang taas kay nga rejection rate. So, ang ilahang rejection rate is 90%, right? Or 95%, but out of 100 applicants, only 5 will be admitted. Next is, suppose you want to examine the spread of infectious diseases. So this is very timely because we are experiencing pandemic right now of unprecedented event. So it's a infectious disease nga transferable siya from humans to humans. It can happen very, very fast. Okay? So suppose you want to study this one, so you can do some assumptions here, or ang unsa iyahang mga key players ani, right? So in this case, we will try to model nga there are certain population nga susceptible sa kaning disease, and how many initial infected individuals are there in your problem, and what is the coefficient, or maybe the value, or how fast the disease will spread from person to person. And you can also keep track of the people that are infected along as you go through sa kaninga model, and keep track also of the people that have recovered and who are dead. And another interesting scenario is the study of mechanism of gossip. So giunsa man pag-spread ang gossip? Have you ever wondered ganung paspas giunsa pag-spread ang gossip? Let's say naa kay secret nga gusto i-share, then you have one person in mind only to share this secret. Let's say you want to share the secret with your best friend. Then ingon man jud ka sa best friend nga nako istorya sa imo ha. Ayo biyag saba ha. So kana siya nga statement is di gina siya mahitabo, right? Kay most of the time spread gina siya. So storya ka karon mo na kay secret sa imong best friend, and pagkaugma it was known already by your neighborhood or even sa tibuok city ninyo sina. So the question now is, unsa man pag-spread ang gossip? Unsa ang mechanism? Similar ba siya sa pag-spread sa disease? Maybe. So that's the idea of modeling. So you have your question and then you try to answer it. Saan mo siya pag-attack sa kaninga problem, because after all, this is all about problem solving. So in this course, we'll be focusing on the idea of problem solving done in mathematical modeling. Okay? So as you can see, if you review sa ang course outline, most of the things nga ang i-discuss kay also all about mathematical modeling and numerical analysis po nga level. We have spread of disease, we have vast diffusion model, and we also have Monte Carlo simulation, and many more. So that's all, and maybe within this week I will be giving exercises or things that you can explore and work on for get used to mo sa idea of mathematical modeling in research. Stay safe and God bless.